Hi, I'm Peter Cowan, the Bee Whisperer. I want to talk to you a little bit right now about why the polar vortex that we're getting now can be such a problem and be much worse having a polar vortex in February than it is in January. So it's middle of February, we've got a polar vortex. And what's that mean? It means really blasts of really cold air has come down from Canada and is now covering most of North America, most of the continental United States. So what I want this video to be about today is why a polar vortex in February is so much worse for my bees than having one, say, in January. So the polar vortex means that we're getting temperatures now during the daytime of 5 degrees, 10 degrees, 15 degrees Fahrenheit. See, 5 degrees Fahrenheit would be about minus 15 Celsius for those in the rest of the world who use a proper system of temperature. The bees are all wrapped up here, so my own hives, I'm not too worried about the problem of the polar vortex, but there are issues that these cold conditions can lead to, even though the hive is pretty well wrapped up. But particularly for those that aren't wrapped well, say they've just got tar paper on, and particularly those with tar paper on, those have a real problem. But those without insulation to a significant degree will have some real problems. And the best way for me to describe them is to draw them down. So I'm going to go in out of this freaking cold and draw some pictures for you to show you what I mean and why really cold temperatures like this polar vortex in February is worse than having it in sometime like January. So let's see what happens when we're in a position of the temperatures changing. Best thing to do, first of all, is to see what happens normally. So we've got a graph like this with number of bees, and this is time. This is December, January, February, March, April, May. And the number of bees, we go into the winter with a lot of bees. Maybe in the fall it's 50,000 or so. By the time we're in December we might be down to 30,000 or so. The number of bees is dropping through January, and in February it's fairly low. And then as the brood rearing starts to build up, the colony grows, and then the population rockets back up to 50, maybe 100,000. So what does the colony look like when this is happening? Let's take the example of a double deep, two-story hive, full of honey at the top, and we start the winter with a cluster of bees pretty much occupying the entirety of that bottom super. Lots of bees, good and strong, eating all the honey that's in here, and still plenty of honey in reserve. In January, we still have plenty of honey up the top, and our cluster has moved up somewhat, but the cluster is somewhat smaller because there's fewer bees, and it's colder, so the temperature of the cluster of bees has to contract to keep warmer. We're talking about here is a fairly consistent temperature, just to give you an idea what would happen then. In February, the bees eat some more honey, and the cluster is a bit smaller because there are fewer bees, and they're up near the top. In March, the bees are right at the top, and they are probably occupying an area something like that. Hopefully the cluster is starting to grow in March somewhat. In April, starting to run out of room, that cluster is starting to grow and hopefully filling a lot of that brood chamber. And in May, let's just move it over a little. May, now we've got a hive full of bees, and we may be looking to reverse the brood chamber for them to rapidly grow into that empty brood chamber up there. That depends on the temperature, and that'll be subject matter for a different video. So this is what would happen normally. Big cluster moving up, moves up, but it's getting a bit smaller. It's a bit smaller still. It's about at its minimum February, March. Eating the honey, start rearing more brood, getting a little bit bigger, getting bigger still. Now, what happens with temperature? If we're having, take January for example, we had a very warm January this year. We're a good 5 degrees above normal throughout January. So instead of the cluster being this big, the cluster was probably about this big. And remember, and it's not that there's more bees, it's just that the cluster is more spread out. It doesn't have to be quite so contracted. To keep warm, the bees huddle tightly together. When it's cooler, they can cover more area. If they can cover more area, they're covering more food, so they have access to more food. Everything's safer. Remember, all the food down here is gone. There's no food left down there. Typically, in this scenario, there's no food down here. They've eaten all of this food. That's all gone. Just have honey stores here. Now, what happens in a warm January this year is that in the center of this cluster, the bees started to rear brood. And I would say that by the 3rd or 4th week of January, we had quite a bit, we had a good softball size cluster, probably covering of brood. So the center of this cluster, the warmest part, reaches 98 degrees. They start to rear brood. Now that brood is going to take about 3 weeks to hatch or to emerge. And as it emerges, they put more brood in there, of course. And as it gets warmer, they might extend the brood a bit further up. Now, that means that this cluster's gone into here, and we've got some brood here. And as the brood emerges and the queen lays new brood, those bees will not leave that brood. They will keep that brood covered up. So this cluster may very well have extended down here, keeping the cluster warm. The same brood here is here. They've got to keep it warm, so they can't go anywhere. They're anchored to that one spot in the colony. Now, the polar vortex has come along, and instead of it being an average, what it should be this time of year is 30 degrees. And the temperature right outside this morning, right now, is 10 degrees. So it's 20 degrees below what it would, on average, be expected to be during the day today. Now, it's within the normal range, but we're in one of the colder parts of that range. Now, as we said before, if it's cold, the cluster has to contract to keep warmer. And they're going to contract around the brood. So this cluster is now maybe that size. And what's happened now? They're anchored here, so they would prefer, if they could, they'd be up here next to the honey. But they're not. The brood is anchoring them to this spot, and this area has already had the honey eaten from it. And now what happens is, if there's still brood here, and it takes a few more weeks to emerge, the cluster runs out of food. If it stays cold, the cluster can't reach any food. The cluster might be able to go like this, or like that, and reach a little bit of food here, or a little bit of food here. But once that, of course it's three-dimensional, so it'll be going round. But if they can't reach any more, eventually this runs out. That runs out, and you end up with a frame of bees. Let's take a frame here. If we took this frame here, what would happen is our cluster looks like this. We've got some brood here, full of capped brood. And we've got bees all around it. empty comb here because they've eaten the honey. And honey here. And honey here. And this cluster of bees starves to death. With this food, all this honey, pounds and pounds and pounds of food, only an inch or two away, maybe an inch, because the clusters had to keep tight to keep that brood warm. Their top priority is keeping that brood warm, but now they can't reach the honey out here, and they starve to death. And that's the danger of the polar vortex. So this is why insulating the hives is so important. And there's two real things if that can go wrong with the with cold at this time of year. That's why the polar vortex, the cold late in February, starts to be a problem, because had it happened in January, we had enough bees to cover a much bigger area of honey. The cluster of the brood had only just been started, so it was near the middle of that brood chamber. And so in January there were more bees to cope with it. They covered more honey so they could last longer. In February we have fewer bees to cover it. They cannot reach much more honey than they already do, and because it's cold and that cluster's contracted. So we end up with the colony starving, even though it's full of honey. Now, the other problem with weather like this, bright sunny day, if a colony is not in a position, not well insulated, here's our colony. If we have a tar paper around the hive, makes it nice and dark, and during the daytime, this is wonderful for the bees. The heat of the hive, if you take a heat gun and measure the temperature of the hive, I'm telling you, a black hive in a sunny day like today, even though it's 10 degrees outside, the outside of that hive is going to be about 85 to 95 degrees Fahrenheit. That heat penetrates the wood, and now that cluster, who've been trying to keep warm, suddenly starts to expand because the heat in the hive is getting bigger and getting higher, I'm sorry. And as that gets warmer still, once the temperature in that hive is above 38, 39 degrees, the bees are now free to move all over the hive. And with that black tar paper on, it's warming up the hive. The bees are able to move. This is great temporarily because they're accessing more honey. But all of a sudden, what happens around 5 o'clock, that sun goes down. And instead of the heat beating in, warming up that hive, suddenly the heat is radiating off the hive. And it radiates out quickly because there's no insulation to keep that heat in. And now that temperature drops from, let's say, what the bees feel like it must be 70 or 80 degrees outside. What's happening now is it's down to 0 degrees. It's actually 70 degrees colder than they were prepared for. And the bees literally do not have time to get back into that cluster to keep warm. And what happens is the bees have to form little clusters all over the hive. They group together and they form little baseball size, tennis ball size, golf ball size clusters, and those clusters are just not big enough to keep warm, and these all die that night, leaving a very small cluster in the middle, maybe a softball size cluster, grapefruit size cluster here, which given a few nights of 0 degrees is just too cold, and they die too. And so that's why it's very important in these northern climates to insulate the hive, because whilst the wrapping with tar paper can be beneficial if they're not going to experience prolonged cold or a sudden drop to extreme cold, tar paper provides no insulation value to the hive. If there's no insulation, the heat can radiate out, and when that daytime temperature goes down like a stone at sunset, you lose all the bees and they die in little clusters. So if you find your hive has lots of little clusters around the corners in particular, and a relatively small cluster in the middle that's died, that's why. You'll want to wrap up better next year. So I hope that video there showed you something about what happens in the cold, and why insulation is so important, and why in particular the polar vortex at this time of year can be a real problem for the bees. I'm Peter Cowan, the Bee Whisperer. See you next time.